like this. The cover, they changed the cover. This is custom published for El Camino. Essentially, it's a pretty expensive book, unfortunately. But Crocolici, the latest edition, 6th edition, 7th edition, whatever. If you decide to get an older edition, it's probably fine too. I don't think they changed the homework problems in this. So just one of the more recent editions, Crocolici and Peters. You'll need this, item number 2, which is the Chemistry 4 Supplement and Laboratory Manual. It's loose leaf and it's shrink-wrapped plastic cover on it. So you'll see that. You'll see it right next to our textbook. So when you go into the bookstore, you look for Chem 4 Chabal, and then you'll look at the required materials. Both of these are there. Okay, item number 3 is non-programmable scientific calculator. So a lot of people, they have expensive calculators like the programmable TI XXX. Those are very nice calculators, but these aren't officially allowed in this course, nor Chem 1A or Chem 1B. What's allowed are the SAT GRE calculators, and those you can't program any information in there. Okay, those would be non-programmable. But there are different levels of non-programmable calculators. If you're continuing in chemistry, then you'll want to get one with equation solver. So don't go for the cheapest one. The cheapest one's like less than $10. You want to go for the next level up, because the next level up is going to have an equation solver function, which is going to come in really handy for Chem 1B especially. And so the calculator I use is this one. I use a Casio FX 115 ES Plus scientific calculator. So right now, I guess it's on sale. You know, I bought mine at, I think, Target. It was 16. I can't remember. It's been a while. But right, I guess it's on sale at Office Depot. Is this Office Depot? Or Amazon. Amazon's about $16. And so you'll want to get the $16 to $20 calculator. And the nice thing about this calculator is it solves quadratics, rapidly. In Chem 1B, you have to solve a lot of quadratic equations, and it's tedious using a quadratic equation. It's much easier if you can just plug in A, B, and C, and then get x1 and x2. Not only will it solve quadratics, but it will also solve third-order equations like ax cubed plus bx squared plus cx plus d. And so sometimes you have to solve third-order polynomial equations. So that comes in handy. If you get to higher orders, it doesn't solve those. You need a better calculator to do that. But this is, from what I've read, this is the most powerful calculator you can have that's not programmable. And this one's still allowed on standardized tests. So it's a good calculator to learn how to use. There's equivalent. There's a TI. It's equivalent to this, and also other manufacturers have something. So something looks comparable to this one. This is the one I use. But of course, you can use whatever one you want. And so I recommend getting a decent calculator. If you already have an expensive $100 programmable calculator, this would serve as a good backup calculator. And worth getting. If you're going to be at one of those office stores or our bookstore carries these as well. These are just composition notebooks with a sewn binding. Well, I want a sewn binding so that the pages are permanently fixed in here. We don't want like a spiral bound or any other type of graph paper ruled notebook where you can tear out the pages. Okay, the pages are meant to stay. And so this would be the cloth ruled composition notebook with sewn binding. I got this one at Staples on sale. It was $1, but they're around $2. At our bookstore, they're around $3 maybe. Our bookstore has a little bit bigger format. It's a black and white cover. It's a nice one. But they're in the engineering section, not the chemistry section. And so you'll need this for lab. we're going to take down what we call our laboratory observations into this notebook. Some people get two of these. They use one for lab and one for homework. They want to keep all their homework in one notebook. It's pretty handy to have. Safety goggles. These are available at the bookstore. There's only one type of goggle that's available. It's the visor goggles. They have a green visor or a blue visor on them. And you might have safety goggles at home, but we have to be careful. I need to take a look at them before I can approve them, because a lot of safety goggles are made for impact protection, to protect you from flying debris. We need safety goggles that are designed for splash protection. And so some people bring in goggles, they have a whole bunch of vent holes along the bottom, but most of the splashes come up from the bottom, and so they don't protect you well enough. And so if you have other goggles, I'll need to take a look at those and see if those will work in our chem lab. Otherwise, you can get these at the bookstore. I think these are under $20. All right, so these are the required materials here. Optional materials, like a Sharpie pen for labeling glassware. It's really handy to have. But I will have some loaner pens available, so number one is not so critical. If you want your own, then get one. They're cheap. Item 2, lab coat or apron. Our bookstore started carrying lab coats as well, or you can get them on Amazon. The last lab coat I got was off Amazon. It cost, I think it was about $17, but it was a synthetic material. Before that, I purchased a cotton lab coat, which is a heavyweight cotton, and that was over $100. And so this is required now at UCLA. All the UCs require lab coats for any chem class, whether it's introductory or advanced. Not only that, all UCs now require gloves, nitrile gloves. Latex or nitrile, either one of these are okay, but nitrile is better. Nitrile gloves have better chemical resistance. These are disposable gloves. They aren't meant to be used the entire semester. In fact, gloves they absorb some of the chemicals, so eventually what's going to happen is once they get saturated, then things can permeate in and out of the gloves. So after a while, you have to be careful with those. So they have a finite, depends on what the chemical is. Some chemicals can go right through it, other chemicals permeate at a very slow rate in the gloves. For most of the chemicals that we're going to be working with, these are water-based, and so nitrile provides really good resistance to those. The same with latex. Latex gloves will provide good resistance. Nitrile are a little more comfortable. They breathe a little better. When I first started wearing, I didn't like wearing gloves because they were cumbersome a little bit. But nitrile are not that bad. You get used to it. So that's optional. Here. These are the materials. You can find this on the handout that's posted on the kiosk. I'll talk about the rest of this handout later. All right, any questions on this? The required optional materials? All right, also on this, the syllabus. Let's take a look at the syllabus. Today we're jumping right into the material, starting with chapter 1. We're going to go through chapter 1's short, so we'll finish it today and we'll start chapter 2. We'll finish chapter 2 this week. Chapter 2 is a bit longer. Chapter 3 is much longer, so we need to get into chapter 3 by Wednesday. Probably start it here. So chapters 1, actually on Thursdays are lab day. So we're going to start with experiment 1 at the end of this week. Now the times, all the times will be the same. The end times are different though. On Monday and Wednesdays we end at 4:05. On Tuesdays at 3:50, so we get out 15 minutes earlier. And then on Thursdays we end at 5:10. This is about a 3-hour, 10-minute lab period with this. We're pretty much going in numerical order here, chapters. I'm not going to jump around. And what I did was I spaced out the exams. We're going to have 4 midterm exams. So the first exam, exam 1, will be the 4th week, first, second, third, 4th week, end of 4th week. Exam 1. You can see the material is pretty much going to cover here. Then by the end of the 8th week, we'll have exam 2. 8th week. And then the 12th week, the end of the 12th week, we'll have exam 3. And then we have a 16-week semester. And so at the end of the 16th week, we're actually going to have our final exam. But we're going to have one more midterm before that. So from the 12th week to the end of the 15th week, we'll have exam 4. Exam 4 was covered this earlier. The final exam will be a comprehensive final. So you're only going to have 1 week here. But a lot of schools, like UCs, what they do is they have a dead week in which you only have finals. Here we don't have a dead week. Here, during the final exam week here, I'm going to have to cover additional material like chapter 19. That would be covered on the final here. So what you have to do is you have to stay on top of the material so that there's not too much review here. Otherwise it can get overwhelming, the amount of material that we have to go back through. I mean, this is a pretty big book. We're going to cover this book. Not all of it, there's some extra chapters in here. But it's like 700 pages. Big book. Alright, actually we're just going to go through chapter 19. There are 22 chapters in the book. So we're going to skip some. The end. Alright, so that's the course in a nutshell. We'll, again, like I said, we'll look at some more details later. Also, what I've done here is, there's one more. I'll take some recordings of the lectures. Not always. Sometimes I'll have some technical glitches, but if you need, or if you didn't catch something, you can go back and check. This is one thing I liked when I was a student, is if I could record the lectures, either audio or audio and video. It just helped me because I'm not a very fast note taker. So, not that people take, it depends on what class it is. You know, this is Chem 4, so probably not that many people take advantage of it compared to Chem 1A or Chem 1B. You'll see a lot more people take advantage of that. Okay, another thing I'm going to post on Piazza are PowerPoints. And I'm going to use PowerPoints this semester. So this is a PowerPoint from chapter 1 here, Introduction to Chemistry, and an Introduction to Active Learning. So I haven't posted these yet, but I'll post these today, so you can take a look. It doesn't mean, these PowerPoints are written by the publisher, and they pretty much follow the book. However, I'm going to deviate from the book at times. So I left the I didn't change the PowerPoints, I didn't modify them because I wanted to more clearly show you where I deviate from the book. And so you'll see it here. So I left these as is. And so we're going to jump into things right now, chapter 1. First we go through the table of contents here. We look at the table of contents, 1.1, Introduction to Chemistry, Lavoisier, and the beginning of experimental chemistry. 1.2, Science and the Scientific Method. 1.3, the Science of Chemistry Today. And then 1.4 goes into learning. You know, these are tips on how to better learn the material. He emphasizes things, which is active learning and the choice. So that's chapter 1, table of contents. But you guys are taking chemistry, so you want to learn about chemistry, right? And so when we think about what scientists do, what do scientists do? You know, do scientists do? What do chemists do? You know, and so if somebody asks you, what does a scientist do? What would you tell them? They do experiments. They make observations. What else? Do experiments. Usually when I think about experimentation, I think of experimentation as taking very detailed observations, you know, very, they call quantitative observations. They want a lot of numbers, you know, they want to measure things kind of precisely so that they get as much detail as possible. And so they'll take, and oftentimes we'll say experimental observations, you know, to emphasize that. These are observations based on experiments. And so scientists, when I think about science and scientists, I think about scientists observing nature. That's what scientists do. They observe nature, right? Biologists observe, you know, living things. Geologists observe rocks and minerals. I was a geology major. In fact, that's what I started off as, a geology major. And I stayed a geology major until I hit mineralogy. And when I got to mineralogy, we were studying techniques for identifying minerals. So we'd get an unknown mineral and we'd have to figure out what it is. And so how did we figure out what this unknown mineral is we looked at the shape of the crystals. You know. We looked at the color. We did something called a scratch test. Have you ever heard of a scratch test? You take a porcelain plate and scratch it. And you see what color the powder, the residual powder is. On the scratch test, the mineral has to be softer than the porcelain plate. I mean, if you took diamond and did the scratch test, the diamond would just leave scratches and the white powder from the porcelain plate. That type of stuff. And then when I got there, I was thinking, wow, this is not very sophisticated. You know, I was taking chemistry at the time, and chemists were using instruments and all kinds of other stuff. And then something that stuck in my memory was that the professor said, you know, even with mineralogists, professional mineralogists who've been in the field for 30 plus years, they still misidentify minerals. And I'm thinking, misidentify minerals? How can that happen? You know, how can you misidentify a mineral? You know, with all the technology that's available now. So then I really started thinking, well, I'm going to switch my major to chemistry because the chemist probably wouldn't misidentify minerals, right? And so I did that, but that was pretty naive because, of course, they were talking about identifying minerals out in the field. You know, the geologists use all the sophisticated instruments that chemists use, you know, as well, but, you know, they can't carry them on their back out in the remote parts of the world. So this is why they have some other techniques for identifying minerals. But I think another reason I switched to chemistry is because I wanted to understand how things worked in the world. You know, many things are quite mysterious, like this table. You know, this table is kind of like a black box. You know, what's inside this table? Why does this table have these certain properties that it does? I wanted to understand those types of things in more detail. This would be like, you know, if you want to become a dog expert, you know, how would you become a dog expert? You know, well, you'd observe dogs. Maybe you shouldn't do, well, it depends on what type of experiment you're doing. You know, does the dog like dry food or, you know, canned food or freshly prepared food? I think I can predict the results of that experiment, but you know, it's the same thing. So if you want to understand nature, right, you got to take observations. You got to see what's going on in nature to understand. And so, what chemists study is, and this is another reason why chemistry appealed to me, is what chemists study is they study matter. You know, well, what is matter? You know what matter is? Yeah, it's everything. It's all the material in the universe, the physical material in the universe. So if chemists study that, then they'll have a pretty good idea about understanding many things. And so eventually I switched my major to chemistry. You know, a lot of people do this. They switch. For example, one of my roommates at UCLA, he started off as a psychology major. Then switched to biology, and then switched to history, and finally finished as a history major. But let's follow along the book here and continue with this. So scientists are good at observing nature. Why do they want to observe nature? Well, it's the same thing. If you want to understand dogs, you probably want to observe dogs, right? And so what we want to do is, for example, here, it says chemistry, science that studies how molecules behave. I don't really like that definition very much, because is everything in the world made up of molecules? You know what a molecule is? Like, you probably heard about a water molecule H2O. But it turns out not everything is made up of molecules. We have other structures that's made up of, like atoms, etc. So this particular definition is a bit too narrow. But what are molecules? Molecules are the smallest unit particle of pure substance that can exist independently and possess the identity of the substance. Well, that's not entirely true. Like gold, is there such thing as a molecule of gold? Well, the smallest particle of gold is not a molecule. The smallest particle of gold is an atom. So why am I bringing this up? I'm bringing this up because this is how the book is presenting it, but here I'm going to deviate dramatically. In fact, this slide, I want to skip or delete this slide entirely. But I'm going to leave this slide in because, must have said something about this in the book, right? This next sentence I like, which is chemists ponder on things that make up the universe, such as molecules. But the things that make up the universe aren't entirely molecules, so this is over-biasing molecules. In fact, this definition I don't really like, this introduction to chemistry. I prefer the dictionary definition of chemistry over this definition. The dictionary definition, I ended up including in the course information sheet, which is on Piazza here. So let's take a look at the dictionary definition. And so when I think about chemistry, what chemistry is this. Chemistry is the composition, structure, properties, and reactions of a substance. What are substances? Substances are the things that make up the universe, the things that make up the world. Substances might be molecules or they might not be molecules, so it's a little bit better. Or we could say the composition, structure, properties, and reactions of matter. Matter is the physical material of the universe. And matter consists of substances. We'll talk about all the definitions as time goes along, but this is number 2. But number 2 is not perfect either, and so this is where I say, okay, sometimes we deviate, or I'll deviate from the book. Now, if I deviate from the book, what should you concentrate on for the test? On the test, are you going to be memorizing about molecules, or are you going to be thinking that the world and the universe is made up entirely of molecules? Or well, I really haven't told you. Or the world is made up of, in other words, matter and substances. Well, you would want to, since I write the test and I grade the test, you'll want to focus on what I'm thinking. Not necessarily what the book's thinking, not necessarily what this definition is thinking, because I'm going to deviate from this definition as well. This definition is from the American Heritage Dictionary here. And so I would have modified number 2. And this says the composition, structure, properties, and reactions. And the way I would modify this is because of the way chemists define properties. The way chemists define properties is a little different than the way this dictionary definition is defining properties. Because the way a chemist would define properties there are 2 types of properties that chemists think of. One type of property is called physical properties. Physical properties would be like the hardness. I know that diamond will scratch porcelain because diamond's harder. Diamond has a hardness of 10 on the Mohs hardness scale. Have you heard of the Mohs hardness scale? And so diamond's at a 10. Porcelain's quite a bit below that. And so that would be an example of physical property, hardness. Are there things harder than diamond? That is there something with a hardness of 11? Diamond's a 10. Can we have something harder at 11? Actually, there are things that are harder than diamond. Synthetic things that people have made, trying to make things that are. And so properties would be like that, hardness, or it would be like boiling point. Boiling point. What temperature does it boil at? Melting point. What temperature does it melt at? The crystals. Density, color. Those are physical properties. We also have one other type of properties called chemical properties. Like, is it flammable? Will it burn? Will it combust? Those are chemical properties. Well, flammable, that's what we call a combustion reaction. And so reactions are chemical properties. And since reactions are chemical properties, then we don't really separate. This would be better stated as the composition, structure, and properties of a substance or matter. Whereas the properties would encompass both physical and chemical properties being reactions, like combustion or flammability or that type of stuff. And so as we go along, I'll probably either follow along very closely or deviate at times. In this case, this slide and this is way too narrow. Chemistry just doesn't study molecules; it studies other things as well, in addition to molecules. And we'll talk about what other things are there in addition to molecules that make up the universe. You know what the most abundant, or one of the most abundant species in the universe is? Is it molecules? Well, one of the most abundant species in the universe are hydrogen atoms, not hydrogen molecules. So we'll talk about atoms later. But before that, I'll come full circle around back to this. But before that, let's talk about Lavoisier. So chemistry had its origins in alchemy. And the alchemists, they had, one of the major goals that alchemists had is they wanted to convert lead into gold. And so they were trying to transmutate lead into gold, and they tried many, many different experiments, many different techniques to try to convert lead into gold. Were they successful? Were the alchemists successful in converting lead into gold? No. And so some alchemists devoted their entire life to it, but weren't. And another thing that they were after is the elixir of life. This elixir of life, I think, is something that prolongs your lifespan or makes you maybe immortal. They weren't successful there either. But then it started to deviate from those goals, and Lavoisier is thought of as the father of modern chemistry because he's the one who just started taking observations. And then seeing what happened. Then he published this manuscript here in 1789, and detailing some of the experiments that he did. The experiments are just really detailed observations, and he formulated theories. Okay, I'm not going to test you on this Lavoisier or what he did, but up to his beginnings in chemistry, people had widely accepted this phlogiston theory, in which all matter that burns contains phlogiston, and when you burn something, that phlogiston is lost and ash remains. But Lavoisier burned different things. He burned some phosphorus, and he burned some mercury, and this contradicted this phlogiston theory.
based on experiments. We aren't going to get into the details, but based on these experimental observations, you came up with some kinds of conclusions. So here's some phosphorus burning in the bell jar or with a balloon attached. When the phosphorus burns here, some of the air is consumed. So there's less air in the jar after burning. Same thing happens with mercury. Here's an experimental apparatus for burning mercury. Here. And the air that was in there was consumed. And so what do you do? Well, you take some observations, and then we continue with those observations and thinking. And so what I want to talk about is what scientists do in their studies. This is the scientific method. Okay, when you look at the scientific method here, let's take a look and follow along from observation, which would be the experiments, skepticism, predicting, testing, revising to hypothesis, theory, and law. And so we're going to look at that in detail. But I'm going to stop here